In this video, which is for section 7.4, I'm going to continue to talk about another thing that we can do with compound interest, which is why I called this video part 3. So in the previous section, I explained how to calculate compound interest, but I actually made an unlikely assumption. I deposited money into my account, and then I never deposited any more money. Now with a normal bank account, one deposits and withdraws money as necessary without much of a pattern. So this makes this incredibly difficult to model. So I'm not really going to talk about that situation. Instead, I'm going to talk about a similar situation that is much easier to model. So suppose you open a retirement account that has 8.4% interest compounded monthly. Well, if the interest is going to be compounded monthly, that means that we have to take 8.4% divided by 12 to get 0.7%, and that is going to be added to our account every month. So if you invest $100, you will have $100.70 after the first month and $108.73 after the first year. If you're not sure how I got those numbers, you should go back and look at the videos from 7.3. Now, this is assuming that you invest $100 and you never add any more. But usually when someone invests in a retirement account like a Roth IRA or other assorted investment accounts, one actually adds money on a regular basis. So suppose that after you initially invest $100, you add another $100 to your account every month. So let's look at what happens in that situation. So the first month you deposit $100, you earn 70 cents in interest, so now you have $100.70. The second month you deposit $100, so now you have $200.70, and after the interest is calculated, we have $202.10. Remember, we calculate the interest by taking the money in our account, $200.70, and multiplying it by 1.007 because it's a 0.07% interest rate, or 0.7% interest rate, excuse me. Anyway, we have $202.10. So for the third month, we deposit $100, so now I have $302.10. Calculate the interest, I have $304.21. So fourth month, same thing, we deposit $100. Now we have $404.21. Calculate the interest, we're up to $407.04. So this is a little bit tedious. So I want to look at it a different way. So going back to the first month, we deposit $100, earn 70 cents in interest, so we have $100.70. The second month, we deposit $100, we have $200.70. And after the interest is calculated, we have $202.10. But another way of looking at the calculation is like this. First, I had $100.70. If I did not deposit any more money, I could calculate the interest, and that would bring me up to $101.40. But the interest on $100 is still 70 cents. So from that new 100 that I deposited, I've earned $100.70. So I had $101.40 plus $100.70, and that gets me the same value of $202.10. And I think I made it harder, but there's kind of a point here. Another way to calculate the total amount of money is to calculate the interest on the money that's already in the account, then add the new deposit and the interest on the new deposit. So for the third month, I know that I've had $100 in the account for 3 months. We know how to figure that out. That gives me $102.11. I've had a different $100 in the account for 2 months, so I can figure that out. And I've added $100 in the account for 1 month. So I have these 3 different values that I could add together. So the most important thing to take away from all of this is that we can calculate the total amount in our account by taking the ordinary compound interest on our initial investment plus the compound interest on our deposits. So I am going to make a chart here that shows how I could calculate the amount of money in my account for each month. So the first month I have my initial $100 times the 1.007 to calculate the interest. In the second month I have 2 parts. I have the first $100 times 1.007. That's the $100 that I deposited in month 2. And then I have $100 times 1.007 raised to the second power. That's the $100 that I've had sitting in my account for 2 months. Then the third month, I have $100 that has interest compounded once, plus $100 that has interest compounded twice, plus $100 that has interest compounded 3 times. The fourth month, same idea. I have $100 compounded once, $100 compounded twice, $100 compounded 3 times, and $100 compounded 4 times. And same pattern in the fifth month. So there's definitely a pattern here. I am always adding $100 times 1.007, but I keep ticking the exponents up. In math, there is a thing that is called a geometric series. So if you want to add the numbers a times b to the n plus a times b to the n minus 1 plus a times b to the n minus 2 all the way down to a plus b squared and a plus b to the first, we have a shortcut to add these. And it's a complicated looking formula, but here it is. And this fits our situation exactly because we have what is known as a sum of powers. So here's my fourth month situation that I had in the chart. And sure, I could do all this longhand, but I want to try and use the shortcut. So if I'm matching it up with my formula, A is $100 because that's the amount of money that I'm depositing each month. B is 1.007 because that is the thing that is always getting raised to the exponent. So here's the formula. So all that I have to do is I just have to put the numbers in where they go. A is going to be replaced by 100 and B is going to be replaced by 1.007. So it looks like this if you just stick the numbers in where they go. And then we do some calculations here to work it out and we get our answer of $407.05. When I did this earlier in the video, I got $407.04, and that is because for each step when I calculated it longhand I had to round, but in this situation I don't have to. Generally, banks will use this formula to calculate it out. This works well for you because you get another cent. So after 1 year, which is 12 months, I will have 100 times 1.007 times 1 minus 1.007 raised to the 12th power, and the whole thing divided by 1 minus 1.007. So after pushing some buttons on the calculator, I can get the answer of $1,256.03. After 2 years, which is 24 months, well, the only thing in the formula that's going to change here is the time, so that exponent is going to turn into 24, but everything else is the same. And once I work out these calculations, I get the result of $2,621.72. There is an official formula for determining the future value of an investment. It looks like this. It's kind of complicated looking, but it's not very different from what we've done before. Let's break down the letters. F, as always, stands for the future value. P stands for the initial investment. R is the rate per term. So you have to be careful that you're using the correct R. And then T is just the number of terms that pass. Now, if you're interested, we can simplify the denominator a little bit because 1 minus 1 is 0, so we end up with negative R in the denominator. So that makes this a little bit better. So let's do an example. I am going to invest $50 each month into an account with 9.6 APR compounded monthly. So how much money will I have after 1 year? Well, the future value we don't know. P is $50, our investment each month. Now R, we have to be careful. We have 9.6 APR, but it's compounded monthly, which means I need to divide it by 12. So 9.6 divided by 12 is 0.8, but then I have to convert it into its percentage format by dividing by 100. So R is 0.008. And T is 12 because there are 12 months in 1 year. So now all that we have to do is just stick the values into the formula where they go and then work it out.